We're going to graph a few polynomial functions, and here are a couple steps that we think through as we graph them. So number one, plot the zeros and consider their multiplicities. Remember, you can find zeros by using synthetic division to help factor. We also sometimes use the rational root theorem. Sometimes we factor by grouping. Sometimes we can just have a quadratic-like equation that we need to factor. So different methods for finding the factors, but we do want to find them and consider the multiplicities. And remember, if there's an odd amount of zeros at a specific value, that means it passes through the x-axis there. And if there's an even amount, it kind of bounces. It doesn't really bounce off the x-axis. We can consider the tails. What's going to happen at the end? This we also call end behavior. We could have a little chart as well, odd degree and positive leading coefficient. The left is down and the right is up. So left tail is down, right tail is up. Could be other things that are going on in there, but left hand down, right tail up. Then if we have odd degree and a negative leading coefficient, that switches. So the left will actually be up and the right will be down. Even degree, so for both of these, even degree, they're either going to both go up or both go down. If it's positive, both ends go up. If it's negative, both ends go down. Take advantage of symmetry. Even functions, symmetric about the y-axis. They reflect about the y-axis. We can also think within polynomials, if all of the exponents are even, it will be symmetric about the x-axis. And then if all the exponents are odd, it will be symmetric about the origin. Please remember, a constant is an even coefficient because so a constant might be 7 at the end, but it's 7 times x to the 0 power and 0 is even. Plot some other helpful points, including the y-intercept, and then you can sketch the curve, make sure it's continuous, smooth, and passes the vertical line test. So that's what we think through when we graph through functions, or polynomial functions. So let's take a look at a couple. So here's our first one. First thing we want to do is find the zeros. Now in this case, finding the zeros looks like we can factor this by grouping. So factoring by grouping, remember if the third term here is negative, we want to change this to plus and negative. We're going to group this. So let's go ahead and group and factor. So in this first group, we see that there's an x squared in common. We can factor out an x squared, and we're left with x plus 1. The second group, we can factor out a 9, but better yet, we're going to factor out a negative 9, and we're left with x plus 1. And then we have two terms here, and in those two terms, we have an x plus 1 in common. So just like we factor out the x squared at the beginning here, we're going to factor out the x plus 1, and we have x squared minus 9. And we can finish this off. X squared plus minus 9 is a difference of squares, so this factors to x plus 3 times x minus 3. And our zeros are going to be x equals negative 1, negative 3, and 3. So we're going to go ahead and graph those. Those are all multiplicity 1. there was just an exponent of 1 here, which is odd, so they're all going to cross through. Now let's take a look at our the tails, or the end behavior. So the end behavior, we look at our leading coefficient. That's a x cubed. It's a positive x cubed. So tails, or end behavior, it's odd, which means they're going to go in opposite directions, and positive, so left is going to be down, right is going to be up, and we can even do that on here. So kind of come past your last 0 here, somewhere down here that the tail is going to be down. Over here, the tail is going to be up. We might want to find, well, there's no special symmetry. That's got an odd exponent and then an even exponent, so no special symmetry. And now we can look at some different points that we want to graph. First of all, the y-intercept, it's nice and easy. It's actually the constant here, so -9. So we have a point down here at -9. And then we could find some other ones. Let's just take a look at in between some of our zeros, so -2. There's a couple different places we can put this. We can put this into either form of this function. We can put it into this form where it's factored, or you can put it into the original. It doesn't really matter. I'm going to go ahead and put it in this form right here. So if we put -2 in here, it's -2 plus 1, which is -1, -2 plus 3, which is 1, and -2 minus 3, -5. Which is 5. So this is going to go through the point -2, 5, which is here. We have our y-intercept here. We could choose another point if that's going to be helpful. Let's go ahead and plug 1 in. Let's see what happens when we plug in 1. Again, I'm going to put it into the same form, the factored form. To me, that's a little easier. So 1 plus 1 is 2. We'll just put it in here. 1 plus 1 is 2. Now put 1 in for x here. 1 plus 3 is 4. And then 1 minus 3 is -2. And we get -16. So 1, -16 is way down here. And that's good enough for us to graph. That'll give us a close enough. So we're going to make a nice smooth curve going through our different points. Goes through this 0. Hits that point, goes through this 0. Hits our y-intercept. We don't know if that's the lowest point there. At -16, it could go a little lower, but that is a sketch of that function.